Hello everybody and welcome back to another video on my channel. Today, since we've done a lot of the tests in Infinite Series and just a lot of the things in general, it's time we do something a little more enjoyable and solve a fun Infinite Series problem. Now this is actually a pretty simple problem, but it does require a little bit of creative thinking and slightly disregarding your original intuition about how the problem is. So, I think that's really it. I hope you guys enjoyed the World Cup final that happened last weekend, and let's move on to the video. So, what is this problem? Well, first we have an ant. Now, this ant is on a rubber band, okay? Now, originally, this rubber band is 1 meter long. There we go, that's the rubber band. So, now this ant starts at the beginning. This ant over here. Very good drawing. So this is an ant. Now, basically, you can say every second, this ant moves 1 centimeter along this. So in the first second, it'll go here. 1 centimeter along. But then what happens is every second also, this rubber band gets stretched out another meter. So, in this first second, this ant goes 1 centimeter, and then what happens is the rod becomes 2 meters, or the rubber band. Now, one thing to keep in mind, as I said earlier, it is uniformly stretched. This will come in very handy later. So, the question is, will the ant ever cross the rubber band? Well, originally you might be like, no, obviously not. We're moving 1 centimeter along, and it's being stretched by a meter, so we're just in an endless race against time, and since it's 99 centimeters more, we will never be able to do it. And if you answered that, you are wrong. Now, as I told you in the beginning, you have to disregard some intuition when solving this problem. So, that's what we're going to do. Let's look at it as facts. So, after 1 centimeter, it'll have moved 1 centimeter, which is 1%, or 0.01 of the rod. So, that's good. That's actually quite good, and it's good because we're moving along the rod. Now, it's being stretched uniformly 1 meter. But even if it's being stretched 1 meter, we are still at that 1% mark. So, we're going to have 1 for the first second. Now, for the next second, we cross another centimeter. And that's 1/2% of the total length because it's half of the 1 meter. And again, this is stretched to 3 meters. But that's fine. We still cross another 0.5%. And for 3 meters, we have 1/3, because when going from 2 to 3, we again have crossed another centimeter, and which is again 1/3% of this whole thing. And then it gets stretched again to 1/4, to 1/5, and so on. So, essentially, we just have this big series over here, and so on, over 100. Now, basically what happens now is, let's write it another way. Well, you can say n is equal to 1 to infinity, this becomes 1 over whatever n is. And we divide this value by 100. Now, again, remember that this diverges because it's the harmonic series. And yes, it does diverge very achingly slow. It will probably take the ant a very, very long time for it to travel infinite distance, really infinite time. So, but what all that matters is, since this harmonic series diverges, that means at a certain point, it will be at 100 at some time t. And at that point, we will have crossed the whole distance. And the answer to this problem is yes. Yes, the ant will cross, but it will take the ant a very, very, very long time in order to actually do it. But just because it takes a long time doesn't mean it can't or won't happen. So that's really about it for this video. This is opening up the intuition. I hope it's a more simple and more fun video versus me just explaining another test on top of another test. You actually get to see what it's like to apply infinite series and their principles to problems. So, thank you very much. See you in the next one, and bye-bye.